Good afternoon to all. Let us solve few more problems in this unit. A train weighing 450 tons has speed reduced by the regenerative braking from 50 to 30 kilometers per hour. Okay. So weight of the train, that is dead weight of the train is given, that is 450 tons. Its speed has been reduced by regenerative braking from 50 kilometers per hour to 30 kilometers per hour over a distance of 2 kilometers on down gradient of 1.5%. Okay, so the train has traveled in the down gradient of for 2 kilometers of 1.5%. You have to calculate electrical energy, average speed, and time taken to travel for these 2 kilometers with the tractive resistance of 50 newtons per ton and allow the rotational inertia of 10% and the efficiency conversion of 80%. Okay, so dead weight of the train is given, the change in the speed is given, distance traveled is given, down gradient in percentage it is given, tractive resistance is given, rotational inertia and efficiency conversion is given. Okay, so you can write down the given data and you can determine the accelerating weight. W is equal to 1.1 W. Okay, so where W is the dead weight and W is the accelerating weight. So if you substitute 1.1 into W is dead weight is 450 tons. If you multiply this, you will get 495 tons. The accelerating weight is 495 tons. Okay, write it down. As soon as you complete, inform. Okay. So I hope you people have already written the given data in your notes. Okay, so the distance traveled is 2 kilometers. I'm assuming some notation to represent this distance traveled. Okay, so D is equal to 2 kilometers, gradient G equal to 1.5, tractive resistance 50 newtons per ton, efficiency is 0.8. So the energy available to the reduction of speed. Okay, so speed is reducing due to regenerative braking here. Okay, so the energy that is available due to the reduction of speed, let us assume the energy available due to reduction of speed is some notation E1. Okay, so we already know the formula 0.0107 into W into V1 square minus V2 square. Speed has been reduced from 50 to 30. So I have written 50 square minus 30 square. VWE, you already know, accelerating weight is 495. So you just simplify it, you will get 8490.24 watt hour, and you can convert that into kilowatt hour, 8.49. Okay, you try to solve on your own, you check the answers, and you tell me as soon as you complete. Okay. So in the problem, they have given that the speed is reduced due to regenerative braking over a distance of 2 kilometers on down gradient. So, so speed is reduced over a distance of 2 kilometers on down gradient. Therefore, you can calculate the tractive effort required while going down the gradient. Safety equal to WR minus 98.1 W into G. Okay. So here R is attractive resistance and G is the gradient. So and W is the dead weight. So we just substitute the values. 450 into R is 50 minus 98.1 into dead weight is 450 into the gradient is 1.5. Just simplify it, you will get minus 43. 1717.5 Newton. Okay, since it is okay, ground gradient, you might have got this negative value. Okay, so irrespective of the sign of this attractive effort, the magnitude of this attractive effort is 43,717.5 newtons. Okay, so the energy available while moving down the gradient for a distance of 2 kilometers, let us assume it as E2. E2 is equal to Ft into D into 1000 by 1000 into 3600 in kilowatt hour. Okay, so you just substitute Ft value which is available here 43,717. Okay, and d value, distance traveled, is 2 kilometers, so substitute ft and d in the above formulae, just simplify it, you will get 24.2875 kilowatt hour. Okay, so this is the energy that is available while moving down the gradient. Okay, so we have already calculated the energy available due to reduction in the speed, and we just now we have calculated the energy available while moving down the gradient. Okay, you simplify on your own using a calculator, check the answers, and you inform me as soon as you complete. Okay. So we have calculated the energy available due to the reduction in the speed, that is E1, and we have calculated energy available while moving down the gradient for a distance of 2 kilometers, that is E2. We can determine the total energy available, E1 plus E2. So E1 plus E2, you just add those values, you will get 32.775 kilowatt hour. Okay. So since in the problem they have asked average speed is nothing but the two speeds, they just add them and divide by 2, so 50 plus 30 by 2, you will get 40 kilometers per hour, and the time taken to cover 2 kilometers is distance traveled by average speed. So distance traveled is what, 2 kilometers, and average speed is 40, so you will get 1 by 20 hour. You can further simplify it. I have not simplified, I have simply left 1 by 20. Okay, you just solve it and check your answer. As soon as you complete, inform me. Completed? Okay. Okay. So let us go for another problem. So a train weighing 450 20 in 1000 and it is desired to maintain train speed of 50 kilometers per hour by regenerative braking. And what happened for you people? Slide did not change. Yeah, now it has changed. Okay, a train weighing four. Okay. Something is wrong. Yeah, now it has changed for you. A train weighing 450 tons is going down a gradient of 20 in 1000. It is desired to maintain a train speed of 50 kilometers per hour by regenerative braking. Calculate the power fed into the line and allow rotational inertia of 12% and the efficiency of conversion is 80%. Okay, traction resistance is 50 Newton per ton. Okay, so in this problem, the data given is almost similar to the previous problem, isn't it? So train weight, dead weight is given, that is 450 ton, and gradient is given, that is 20 in 1000. So you can determine the percentage gradient 20 by 1000 into 100, and train speed must be maintained, means maximum speed should be 50 kilometers per hour. Okay. 50 kilometers per hour by regenerative braking. Calculate the power fed into the line. You have to calculate the power fed into the line and the rotational inertia of 12%. Okay, so the efficiency of conversion is 80%. Traction resistance is 50 Newton per ton. Okay, so dead weight of the train is this, and maximum speed is 50 kilometers per hour, and G is equal to 20 by 1000 into 100 is the percentage gradient. Okay, so you just write it down as soon as you complete in form. Okay, so we have calculated the percentage gradient. Okay, I hope you people have written the given data in your notes from the question. Okay, retractive resistance is 50 Newton per ton, rotational inertia 12%, efficiency of conversion 0.8. So we can calculate the retractive effort required while going down the gradient. Okay, so wait. So Ft is equal to, so Ft is equal to Wr into 98.1 into Wg. That formula is well known to you. So W into R you already know. So W is the dead weight, that is 450, R is 50, 98.1 into W is 450 and gradient is 2%. We have calculated in the previous slide. Gradient is 2%, so 2. So you just simplify this, you will get 65,790 newtons. Okay, so if you know Ft, if you know Vm, you can calculate output power. If you remember, we have solved in the other problems earlier. Okay, so P out is equal to Ft into Vm by 3600. Just substitute it here and you check your answers when I vary the slide. Okay, so at present you just solve for Ft and P out also you solve on your own. I will show you the answer as soon as you complete. Okay, inform me as soon as you complete. Okay. So I hope you have determined the P out by substituting Ft and Vm. Vm is 50 and P out just now Ft we have calculated 65,790. Just substitute in this formula and you will get P out is equal to 913.75 kilowatt. Now the power fed into the line is equal to power available into efficiency of conversion. Power available is what? Power output. Power output is 913.75 into the efficiency of conversion is 0.8, 80% it is given in the problem. So you write it as zero point 0.8. You simplify it, you will get 731 kilowatts. Okay. So this is what is asked in the problem, power fed into the line. Okay. You just complete it. As soon as you complete, inform me. Okay, completed? Okay then. Next problem. A goods train weighing 500 tons is to be hauled by a locomotive up an ascending gradient of 2% with an acceleration of 1 kilometer per hour per second. Okay, so there is a goods train. So the locomotive in the train, that is a motor, it has to haul it, means it has to stop it. The weight of the dead weight of the train is goods train is given 500 ton, and the ascending gradient is given, that is 2%, and the acceleration is given 1 kilometers per hour per second. And if the coefficient of adhesion is 0.25, the train resistance of 40 newton per ton, and the effect of rotational inertia is 10%, then you have to determine the weight of the locomotive, okay, and the number of axles if load is not to be increased beyond 21 tons per axle. Okay, so let us determine this. So dead weight is given, train resistance is given, okay, and ascending gradient g is given, and acceleration and coefficient of adhesion is given. Okay, so write down the given data and note down the problem. As soon as you complete, inform me. Completed? Okay then. Okay. So this is the given data. So you know if dead weight is given, you can determine the accelerating weight of the train. W is equal to 1.1 into W. So 1.1 into 500, you will get 550 tons. And track effort formula, Ft equal to 277.8 W alpha plus 98.1 Wg plus W into R. Okay. So this is the formula which is well known to you, and so I have simply I might have substituted directly. I can substitute the values. Okay, it doesn't matter. Okay, but I have taken this W common. Okay, I have taken this W common. If you take W common from this above expression, okay, so what you will get is 277.8 into WE by W alpha plus 98.1 into G into R. Okay, so actually, so 1 minute. Okay. So, okay. So if you do so, WE by W is what? WE by W is 1.1. So W by W, WE by W is 1.1. Alpha is given 1. Okay. And W you have taken common. So your modified formula is this. So W by W1, 1.1. Alpha is 1, 98.1. And G is 2. And R is 40. Okay. You just solve it. You will get FT equal to W into 541.6. We will substitute W value. Don't worry. We even though we know W, we have not substituted here, but we will substitute it later on. Okay. So you just simplify this. You will get this. Okay. So Ft is equal to what? 541.6 W Newton. Okay. I have not written Newton here. So it's Newton. Okay. So you just complete it. As soon as you complete, inform me. Okay, complete it. As soon as you complete, inform me. Okay, completed. Very good. Now, you have determined the tractive effort in terms of dead weight of the train, isn't it? W, I didn't substitute the value, even though I know what is W, dead weight of the train, I have not substituted the value. So you have determined the tractive effort in terms of the dead weight of the train. So inside the train, there is a locomotive which is hauling this train, which is, okay. So let us assume the weight of this locomotive uh, is WL. Okay, WL is the weight of the locomotive. Then the tractive effort will be 541.6 into W plus WL. Okay, weight of dead weight of the train plus the weight of the locomotive must also be considered. Okay, so Ft will become 541.6 W plus WL. So you can substitute W value here. So if you substitute, that is 500. So you will get 541.6 into 500 plus WL Newton. So this is the tractor effort after considering the weight of the locomotive. Okay, locomotive is nothing but motor here. Okay, now coefficient of adhesion formula you already know, mu is equal to Ft by adhesion weight. Okay, so you can rewrite this formula as Ft equal to mu into Wa adhesion weight. So Wa is adhesion weight is nothing but W into G. Okay, so when if W is in turns, then Ft will become 1000 into mu into W into G. Okay, if W is in turns, then Ft is 1000 into mu into W into G, where G is nothing but 19.1. Okay, just write it down as soon as you complete inform. Okay, okay then. So we can determine now the maximum tractor effort. So that is nothing but 1000 into mu into WL into G. Okay. Okay. So where WL is the weight of the locomotive. So 1000 in mu is what 0.25, WL into G is what 9.81. Okay. So I think by mistake I have told 98.1 G. G is 9.81. So So you just substitute Ft here. Ft is what 541.6 into 500 plus WL equal to 1000 into 0.25 WL into 9.81. Okay. So you just simplify it. You will get the weight of the locomotive. So weight of the locomotive is what 142 tons. You will get. Okay. So since the weight per axle is not should not exceed 21 tons. Okay. So the number of axles required is weight of the locomotive by the weight per axle. So number of axles required is 7. Okay. Weight of the locomotive is 142 tons by the weight per axle is 21 tons. Okay. So if you take this ratio, you will get the number of axles required. Okay, that is 7. Okay, solve it, all of you, and check the answers.